My name is Rob Longcore, and I'm doing a project on automation in the trucking industry for Keith Hennessy's GSP class Open Road, Innovation in Cars, Driving, and Mobility. So before I dive into the actual technology behind automation in trucking, I wanted to give an overview of the industry as a whole. So starting with some quick industry facts, there are about 3.5 million truck drivers in the US. 350,000 of those are independent owner-operators, and the rest are employed by large fleets. Trucking accounts for over 70% of all of the freight tonnage moved in the US, so the vast majority. It's a $726 billion industry and accounts for about 82% of all freight revenue, and it's highly fragmented. So the top 50 firms own just 30% of the market. In terms of what it costs to actually run a business in the trucking industry, the big drivers are essentially the human drivers, the fuel required, and the equipment, followed by repair and maintenance and insurance. So we can start to think about where automation could impact some of the major costs of this business. Technological disruption in trucking fall into three main categories, and there is significant overlap between them, but we'll talk about each of them. So telematics is essentially a wireless communications device that's plugged into a truck and allows it to communicate with fleet operators or some other data hub. It can transmit data on fuel efficiency, on speed, and on drivers' hours of service. V2X communications can be vehicle-to-vehicle communications or vehicle-to-infrastructure communications, particularly important in trucking because of applications such as platooning, where several trucks travel together and need to communicate with one another as they travel. And of course, there's the actual automation of the driving task itself, where the truck is equipped with cameras, radars, lidars, etc., and it can automate the actual driving. This presentation will focus mainly on driving automation and V2X communications. We won't focus as much on telematics, but if you want to learn more, you can check my memo. Benefits of automated trucks, they fall into two major categories. The first is automated driving itself. So as I hinted at earlier, drivers can only drive for a certain amount of time before they're required to take rest periods. If the autonomous technology allows them to sleep while the car is still driving, it allows them to avoid essentially having to park the truck and wait until their hours reset. So this is obviously a huge potential for productivity gain there. There's fuel efficiency gains also to be had from predictive driving. So if the truck knows when there's curves ahead or when there's big hills or declines, it can adjust the acceleration or deceleration in the steering of the car to drive more efficiently. Of course, there's elimination of human error, fewer crashes, and just better driving overall. Better vehicle utilization. The truck's fuel economy is maximized at about 55 miles per hour, and it declines significantly for every mile per hour over that. Not all human drivers actually drive at that speed, but having an autonomous vehicle do so would be much more efficient. And of course, they can eventually become driverless, and there's obvious benefits there from removing the human driver entirely. Now, the second main area is cooperative automated driving, otherwise known as platooning. And this is essentially a technique where several trucks drive closely behind each other. They use autonomous technology as well as vehicle-to-vehicle communication to do that. And what it does is it improves the aerodynamics and fuel consumption of the driving. Studies have shown that the improvement in the fuel economy can be anywhere from 5 to 10%, which is substantial. So who are the major innovators in this space? There are several, but I'm going to focus on two main ones today. First is Freightliner. Freightliner is a company that's owned by Daimler and Mercedes. They recently launched a truck called the Freightliner Inspiration. It's an L3 automated production truck licensed to operate in the state of Nevada. It has a highway pilot mode that allows it to drive autonomously on highways. And it was released dramatically with this big PR release at the Hoover Dam. A bunch of people came and they had lights and a big show, and it drove across the Hoover Dam without a human driver at the wheel. And it's also the same technology has been implemented in Germany in Mercedes trucks that have been driving on the Autobahn for the past about year and a half. And the other main company I want to focus on is Otto. This is a San Francisco startup that retrofits existing Volvo trucks with cameras, radars, lidars, about $30,000 of technology, and makes them capable of L4 automation. These trucks, there's about 6 of them on the road today that are being tested on the California 101 right on our doorstep here in Palo Alto. And they actually just completed one of the first autonomous truck deliveries of beer. Potential, there's many areas to focus on here. I'm going to highlight specifically safety, hours of service, and the driver shortage. So the main short-term driver of adoption for trucks like these is probably going to be safety. 90% of truck accidents are caused by human error. So obviously, if you can introduce some autonomous technology that can help reduce that, that would be a significant benefit to society. Now, in terms of hours of service, I hinted at this earlier, but this is essentially a regulatory requirement that forces drivers to take rest periods after they've worked for a certain amount of time. Now, if the truck can drive while the driver's sleeping or taking a rest, that would significantly increase productivity and allow them to spend their time more efficiently. And the last one I wanted to touch on was the driver shortage. So this has largely been driven by a lack of ability to attract and retain younger drivers. So one of the theories out there is that introducing this technology could actually get more younger drivers excited about getting into this business. And of course, the automation technology would actually make the driving task more interesting because you can do other things while the truck is in autonomous driving mode. So that could help with the driver shortage. It could help with driver retention. I'll mention fuel costs later, and I think the other ones are fairly obvious and will be touched on by others. Based on what I've read, the adoption of this technology in trucks will be driven by three main factors really. So safety was the big one I mentioned earlier, but the other two are the level of automation that we're talking about and the type of trucking. So in terms of the level of automation, for L1 and L2 automation, these allow you to achieve a high level of fuel savings from platooning, because you'll still need a human driver to be at the wheel. But if you can use the technology as well as vehicle-to-vehicle communication to put several trucks in a row, allow them to achieve that 5 to 10% savings, there's significant potential there. And then on the higher end of automation, you'll have significant amount of cost savings driven from removing the actual driver from the vehicle itself. If you look at the type of driving you're doing, whether it's long haul, which are trips that are cross country, or regional on roads that have little or no traffic, it looks a little bit different. So for long haul trucking, where there's lots of highway traffic and you're able to platoon with other trucks fairly easily for long distances, there's going to be significant fuel and driver savings there and a shorter payback period to adopting this technology. But if you're traveling shorter distances on roads where there aren't a lot of other trucks to platoon with, you're not going to find the same advantages. And so, for L1 and L2 automation, we're really talking about savings from platooning. And for L4, L5, the savings are going to come from removing the driver from the actual truck. And so there's this weird inflection point around L3 where, the cost of that technology is higher than L1 or L2, but you're not really seeing any significant improvement in fuel savings or driver costs. So we probably expect the transition from L3 to L4 to happen very quickly. My final thoughts here. First, I think, as I mentioned, the commercial benefits of automation are fairly limited today, and I think short-term adoption will actually be driven by safety regulations more than anything. But when we start talking about L1 and L2 automation, I think the level of platooning will have a significant impact on the payback periods there. And this will inherently lead to a competitive advantage for large fleet operators who are able to schedule these platoons much more easily than an independent owner-operator. In the longer term, payback periods will drop in L4 due to driver savings, and platooning will become less important there, because the driver is just such a significant portion of the cost bar, as I showed earlier, that if you can actually remove the driver entirely, that's going to drive the actual payback of adopting the technology, much more so than the platooning effect. And we would also expect potentially new business models to emerge around platoon service providers. So these would be companies that would match potentially trucks from different fleets, match them so that they can platoon together over long distances. or even intra-fleet within one fleet operator's fleet, allow multiple trucks to platoon together and just provide the scheduling services that allow them to coordinate on where they're going, what distances they're traveling, and what their destinations are. And of course, the last thing you have to mention here is that considerations will have to be made for displaced drivers as we start talking about L4 and L5 automation. And this will be certainly a hot topic, and it's something people are already starting to talk about, particularly with the driver shortage that exists today. And of course, the role of drivers may change entirely, such that they may still sit in the truck but do logistics work or other work while the autonomous vehicle is operating on its own. So thank you for watching. Really appreciate it, and I hope you learned a little something about automation in the trucking industry. Thanks.